This is a presentation on the measures of central tendency. Statistics is the collection, classification, and analysis of a set of numerical data. In statistics, it is very important to know how to compute the average. In sports, we use statistics to calculate a batting average. In retail stores, managers and owners use statistics to determine what styles or colors were the most popular the season before. One of the main topics in statistics is central tendency. There are 4 common ways to measure central tendency: arithmetic mean, median, mode, and the mid-range. Each one of these measures may be used, but depending on the situation, one may be better than the other. The mean is also referred to as the average. To find the mean, take the sum of the values, then divide the sum by the amount of data given. The symbol for the mean is X bar. The arithmetic mean is used to find an average test grade for a class, an average amount of shots per game taken by a lacrosse player, or the average amount of sleep a person has per night. In Isabella's statistics class, she has 6 quiz grades. She wants to find her average quiz grade. The grades Isabella received are 70, 82, 85, 90, 80, and 71. Add the quiz grades 70 plus 82 plus 85 plus 90 plus 80 plus 71 equals 478. Divide the sum, which is 478, by the total number of quiz grades, which is 6. Therefore, 478 divided by 6 is 79.66. After rounding up to the nearest whole number, Isabella has an average quiz grade of 80%. The median is the middle number, score, or value in a set of data. If there is an odd amount of data, the median is the middle number. If there is an even amount of data, the median is the mean of the middle 2 numbers. Using the median gives a more accurate number when extreme values are present in the data. When finding the median, it is important that the data be listed in sequential order. After putting the values in sequential order, cross off the first value, followed by the last. Then cross off the second value, followed by the value before the last. This will continue until one final value is left, or until there are 2 middle values left over. If there are 2 values remaining, find the mean of those values. To show an example of median, use Isabella's quiz scores again. The scores were 70, 82, 85, 90, 80, and 71. But these are not in the order needed to find the median correctly. In sequential order, the grades are 70, 71, 80, 82, 85, and 90. There are 6 scores, an even amount of values. Find the mean of the 2 middle values in order to find the median value of Isabella's scores. First, 70 is crossed out, then 90, next 71, then 85. We now have 80 and 82 left as the 2 middle values. After computing the mean of the values, 82 plus 80 equals 162, divided by 2 equals 81. The median of Isabella's quiz scores is 81%. A group of friends, Sam, Harry, Kyle, Nicole, and Steve, all had different jobs this past summer, and they wanted to compare the amounts they each made. They decided they wanted to find the median income. These are their incomes from the past summer. Sam made $800, Harry made $950, Kyle made $730, Nicole made $800, and Steve made $600. Place the values in sequential order: 600, 730, 800, 800 again, and 950. The values are eliminated starting with Steve's $600. Then Harry's $950, Kyle's $730, and Sam's $800. Nicole is the final person remaining with $800. Therefore, $800 is the median value for the friend's income. The mode for a set is the value, number, or score that occurs most frequently. Mode is viewed as the most popular value in a set. There are specific scenarios where the mode is the most appropriate measurement of central tendency. For example, imagine you work for a florist. During a 6-hour shift, you sell approximately 240 flower arrangements. This means you sold 40 flower arrangements per hour. The problem with using arithmetic mean for this situation is that the rate of customers purchasing flowers are different for each hour. Therefore, determining the mode or the most frequent number of flowers sold over a 6-hour shift would be the best form of measurement in this situation. In the same situation, if there are 2 separate hours where 32 arrangements are sold, 32 would be the mode. This set of data is known as bimodal. If during the 6-hour shift, different amounts of flowers are sold each hour, this set of data has no mode. When there is no mode, be sure to write no mode. Do not write the number 0. A data set of 10 numbers represents the number of shots taken by one player in 10 basketball games. The data set is as follows. Game 1, 2 shots. Game 2, 3 shots. Game 3, 4 shots. Game 4, 1 shot. Game 5, 1 shot. Game 6, 5 shots. Game 7, 6 shots. Game 8, 6 shots. Game 9, 1 shot. Game 10, 9 shots. The number that occurs most frequently is 1. Therefore, there is a mode of 1 in this data set. After an entire day of Sunday Night Football, you want to determine the mode for the team's final scores. Calculating the mode will show the number of points scored most frequently among all the teams. The table provided shows the final scores of all the Sunday night games on October 18, 2015. Even though there seems to be a large amount of data compared to previous examples, it is still possible to determine the mode. When arranging the numbers in sequential order, it is important to mark off the numbers as they are used. In order to be accurate in your calculations, organizing large amount of data is imperative. Since the data set has numerous values, there is a different way to organize the data. The way the values are set up resembles a bar graph. When you look at a horizontal bar graph, the x value with the tallest bar has the most values. We can use the same concept when dealing with mode. The smallest value will be the first value on the chart. Then, the next value in sequential order will go underneath the smallest. If there are duplicates, those values are written on the same line. This continues until all the values are in the chart. Now, by looking at this chart, it is easier to see that 20 and 34 are the values that occur most frequently. There were 4 teams that scored 20 points and 4 teams that scored 34 points. Therefore, there are 2 modes, 20 and 34, which makes this dataset bimodal. As stated previously, it is possible to have no mode in a dataset. Suppose John wants to determine if there is a mode for the number of hours he sleeps per night. The data is presented in this table. After rearranging the values into sequential order, it appears that John had a different number of hours each night. Therefore, there is no mode for this set of data. Reminder, do not use a 0 to indicate there is no mode. The final measure of central tendency is the midrange. The midrange can be described as the value midway between the endpoints of the set of data. Although sometimes the midrange can have the same value as the median, they are not considered the same thing. The midrange can be found by adding the least value in the set of data, L, and the greatest value in the set of data, G, and dividing the sum by 2. Use Isabella's quiz grades again as a set of data for this example. As a reminder, her grades were 70, 82, 85, 90, 80, and 71. Similarly to finding the median, the numbers need to be arranged in sequential order. After doing so, the least value is 70 and the greatest value is 90. The mid-range will equal 70 plus 90 divided by 2, therefore 160 divided by 2 equals 80. The mid-range score for Isabella's quiz grades is 80%. Even though the computations of mid-range and median appear to be similar, this example proves that they are not the same. Her mid-range score was an 80, whereas her median score was an 81.